Okay, so remember in our last chapter we talked about base numbers? Kind of. Like 2 to the third, 2 to the fourth, 2 to the fifth, and 3 to the second, 3 to the third, all of those. We're going to be using those in today's homework, okay, on every problem. So we're going to start looking at problems where the variable that we're solving for is actually in the exponents, okay? So what we're going to do is, the first step is always to change everything to its base number. So we're going to look here. 2 can't get any smaller, so that's going to stay the same. But 8 can be changed to a base number. What is 8? 2 to the third. Okay, so all you do on the first step is change it to its base number. Okay, so we did that. Okay, next step is to simplify your exponents. Okay, so right here, 2 to the x, can't change anything there, but what can we do here? We multiply those two because it's a power raised to a power, so it's 2 to the 9th. So what does x equal? Yeah, last step, set exponents equal. Okay, and then there's no solving beyond that on this particular problem. It's just x equals 9 and you're done. Sometimes there's a little bit more algebra to do, but not in this case. Okay, let's look at this one. This one, both the left and the right need to be changed to base numbers. Okay, so 4 can be dropped down to what? 2 to the second. Good. Okay, this one, 2 to the... Someone check on their calculator. 2 to the 6th. Okay. Okay, so that was our first step, change to base numbers. Second step, simplify the exponents. So on the left-hand side, we have to multiply those. So we really have what? 2 to the 4n minus 2, making sure you distribute that 2 all the way through. This one, there's nothing to multiply, so that stays the same. Step 3, set the exponents equal to each other. Okay, so we'll take our 4n minus 2 and set that equal to 6. And now this is just simple algebra, getting n by itself. Questions there? Okay. Let's try one that's a little bit more difficult. Same first step, we have to change everything to its base number. So this 64 we just talked about on the last page is 2 to the 6th power. It's on the bottom. Okay, so that means how else could we write it? What did it start out as if it's down here on the bottom? What would be negative? The exponent? Okay, so it's really 2 to the negative 6 is the same thing as 1 over 64. Okay, so if it's on the bottom, that means the exponent was negative at first. Over here, we'll change 32 to its base number. Two to the 5th. Same first step as the previous two problems. We changed it to base numbers. Next step was we multiply our exponents if we need to, simplify them. So we've got 2 to the what? Yep. 2 to the... Okay, so we simplified our exponents. We set the exponents equal on step 3. So we've got negative 6x plus 12 equals 10x. And now we'll just solve for x. That's a 4, 3/4, or 0.75. Questions there? So keep in mind, if you have a fraction and your numbers on the bottom, just make your exponent negative. We've got one left that's actually one of your homework problems. It's a little bit tougher than this one. Other questions on this? All right, let's try one more. All right. So this one right here, our first step is still going to be the same. So let's change every single number to its base number. Okay, so the numerator, the denominator, everything. So looking over here on the left, we're just focusing on the 25. What's the base number for that? Okay, over 3 to the 4th. Okay, now when you're doing these, we need to have the same exponent on here. So how could we have a 2 looking at the 81? Having a 9? Okay, so we're going to go with 9 squared. So when you're doing fractions, we need the same exponent. Okay, and I'll tell you why in a second. So we're just going to keep that the same exponent out on the outside. Okay, looking here, what about 125? That's 5 to the 3rd. What would 729 be? Check with your calculator. Hopefully it's 9 to the 3rd. Okay, now here's why we need the same exponent. If we're looking at 5 squared and 9 squared, is that the same thing as 5/9 squared? Yes. Okay, so we're going to rewrite this as 5/9, the whole thing squared, with our 2x plus 1 right here. Over here we've got 9/5 cubed with negative 3x plus 1 on the outside. Now what's inside the parentheses is close, but it's not exactly the same. Okay, how do we switch things from the numerator to the denominator? How do we move things from the top to the bottom? We just went through this on the last page. How would you move, for instance, the 9 to the bottom? What would you change on it? The negative exponent. Okay? It doesn't matter which one we switch, but we need to switch one of them so that the numbers flip around. So let's just take this one on the left. If we change this 2 to be a negative 2, then we could flip-flop these guys, and it would still be the same thing that we started with. So we got 2x plus 1, and this one's not going to change at all. Okay, so all I did was change one of the exponents to be negative so that I can flip-flop the numbers. Okay, so now we're focusing on multiplying our exponents right here. So this is really 9/5 to the what? Minus 2. Okay. Over here we've got 9/5 raised to the negative 9x plus 3. So now that we have a number raised to an exponent equal to the same number raised to a different exponent, we set those exponents equal. We've got negative 4x minus 2 equals negative 9x plus 3. And now we can solve. I get 1. So this one is going to help you when you get to the end of the assignment because there's going to be one similar to this, and you can have this as a side-by-side example on how to do that. Questions there? Main thing is following these 3 steps right here on the left. Change to base numbers, simplify your exponents, and then set the exponents equal.